STA 3532 Introduction to Statistical Quality Control, Chapter 3, Control Charts for Variables. Actually, quality characteristics that is measured on a numerical scale is called a variable. In the previous two lessons we discussed about the variables and attributes. Actually, variable is a continuous measurement, so here we are considering with three types of control charts: X bar chart, R chart, and S chart. X bar chart means average. In here we are considering the average. Then R means range, and here standard deviation. So the X bar chart is used to control of the process average or mean quality level. If the process variability monitored by the standard deviation, S chart is used, and but most probably we are using the R charts. Then control limits for the X bar charts, you have to remember those things. Then upper control limit UCL is equals X double bar plus A2 times R bar, center line CL is equals X double bar, and LCL is equals to the X double bar minus A2 R bar, where average of the sample is means X bar we can find all the entries x1, x2, xn divided by n, then we can find X bar. Then grand average means we have to add these averages X bar plus X bar 1 plus X bar 2 up to X bar n divided by m, then we can find the grand average, and we can substitute there X double bar. And also range, R means range, it means maximum subtraction minimum. Then you have to add all the ranges together and divide by the number of entries, then you can find the R bar for there. And also there is some constant, there is a constant called A2. This A2 we can find from the table according to these n values, right? When we are dealing with an example, so you can understand how to find these constants. Then control limits for the R chart, that is range charts, that is upper control limit is equals to D4 times R bar, center line equals R bar, and lower control limit equals D3 times R bar. Then constant, again we can find these constant from the table. And also then estimating the process standard deviation. The process standard deviation can be estimated by using a function of the sample average range. Here sigma hat equals R bar over D2. This D2 also we can find using the same table. And this is an example, so you can understand what we discussed in the previous slides by this example. A break process is used to conjunction with photolithography in a semiconductor manufacturing. We wish to establish the practical control of the flow width of the resist in this process using X bar and R charts. 25 samples, each size 5 wafers have been taken when we think the process is in control. The interval of time between the samples or subgroups is 1 hour. The flow with the measurements in microns, these samples in the table. So here n means number of groups, here 1 2 3 4 5, then n equals 5 here. And n means the number of entries, number of people in the each sample. Here 25 different samples, so m equals 25 there. So when we substitute, we can again discuss with the L and M. Then here we are going to find that X bar charts and X bar chart and R chart. X bar for the X bar we have to find the X double bar and A2, and also for R again R bar we need. So to do this, so first we have to find the X bar of this each samples and also the range. So to do this, so if we need to find X bar, how we can find? We have to add this all. If we need to find X bar, so we have to add this one and this one and this one. If we had to add this all, then you have to divide by the number of entries. Then here how many entries? 5. So after adding all these things we need to divide by 5, then we can find x bar I. Second entry also we have to add this all, then need to divide by 5. Here also same thing we need to repeat. So this is the way of finding x bar I, right? We will do 1 or 2. Here 1.3235 plus 1.4128 plus 1.6744 plus 1.4573 plus 1.6914, then divide by 5. So we can take 1.5118 means 1.5119, 1.5119. We will do another one. 1.4314 plus 1.3592 plus 1.6075 plus 1.4666 plus 1.6109 divided by 5, then we can take the answer as 1.495y. 1.4951. As the same way you can find this all the values, right? Then Ri means maximum entry subtraction minimum entry. So then that is a way of finding Ri. So maximum entry in here, so if we consider this, I think this 1.69 is the maximum one, then 1.3235 is the minimum one. So we can find the range 1.6914 subtraction 1.3235, then it's come 0.3679, 0.3679, and here maximum is 1.61 and minimum is 1.3592. So then we can find range maximum value 1.6109 subtraction 1.3592, then it's come as 0.2517, 0.2517. As this way you can find x bar for this 5 samples and Ri for the that's range for these samples for each and every 25 entries. So after that you can obtain like this graph. So here you have in this one you have to find using the previous method, and this one also. The next step is you need to find sigma x bar I. It means you have to add this all together. If you add all these values together, you can take the answer as try this 37.64, and these all the Ri values if you added, then sigma Ri you can take 8.1302. Try this. And then x double bar means how we can find x double bar. X double bar equals sigma xi over m, x bar I over m. Then x bar I, sigma x bar you found as 37.64. M means the number of entries here 25. and R double bar also you can find sigma Ri over M. Sigma Ri you found as 8.1302, then divided by M equals 25. Then you can find those two values here. 37.64 divided by 25, then value is 1.5056. 1.5056, and next one 8.1302 divided by 25, it's come 0.3252. 0.3252. Now you found the value of x double bar and r bar. There is not r double bar, r bar. So now you can find the control limits for the R chart. So here you know that R chart is equals usual d4 R bar, centralized is R bar, then lower control limit d3 R bar. So you have to substitute this one and find the control limits. So we can write upper control limit equals d4 R bar, and lower control limit first we can write the center line equals R bar, and lower control limit equals d3 R bar. d3 R bar. Then you know that n equals here 5. There are 5 entries in here. N equals 5 and m equals 25. M equals 25. Then you can find the value for these d3 and d4. d3 and d4. Then n equals 25. Since n equals 5, since n equals 5, so you can find d3. d3 is here. N equals 5. d3, this one, that is 0. Then d3 equals 0, and n equals 5. d4 equals this value. d4 equals 2.114. so now you can substitute and find the values. Then d4 means 2.114 multiplied by r bar. R bar equals 0.3252. R bar equals 0.3252. in here also d3 0 into r bar 3252. then lower control limit equals 0. Control limit center line is r bar. R bar means 0.3252, and now we need to find this value. 2.114 multiplied by 0.3252, then answer is come as 0.6874. we can write answer as 0.6874. these are the control limits for the R chart. R chart means that range values. Then here you have to use this, but in when you are doing this examination, that all the values are given in one table, so you have to select the appropriate, that means a correct value set here, chart for the ranges. If you are taking R charts, you have to use the chart for the ranges. Then control limits for the X bar charts, then here you have to use the chart for the averages. Then for the X bar chart, you know that we discussed earlier, upper control limit equals x double bar plus a2 r bar and center line equals x double bar, and lower control limit equals x double bar subtraction a2 r bar. Here 5 samples, then n equals 5. Then you can find a2, since n equals 5, a2, n equals 5, a2, this one 0.577. now x double bar we found, see 1.5056, then r bar we found 0.3252, r bar 0.3252. so we have to substitute x double bar 1.5056, a2 equals 0.577 multiplied by r bar 0.3252, and here 1.5056 subtraction a2 0.577 into r bar 0.3252. so we can 0.577 multiplied by 3252, then it's come 0.1876, 0.1876, 1.5056, 1.5056 subtraction 0.1876, then we can find the answers for this one. 1.5056 plus 1876, then answers come 1.69, 1.6932, 1.6932. this is the upper control limit. Then lower control limit you can find 1.5056 subtraction 0.8176, answers come as 1.3180. then you can write 1.3180. these are the values for the control chart, x bar chart and r chart. Then there is another type of chart we call, that is S chart. These are the control limits. Upper control limits b4 s bar, and center line s bar, and lower control limit equals b3 s bar. These b3 and b4 you can find from the table again. Consider the above example and find the control limits for this one. And here then there is a then earlier that find in the average and that range, that is not a very difficult task. Here if you need to find the standard deviation manually, you have to use this equation. It means SI equals sigma I equals n to n xi minus x bar square over n minus 1. But it is if you are doing the manual calculation, it takes the time, so I think it's the best way is to use the calculator. So I think you know that how to find the standard deviation by using the scientific calculator. Anyhow, I am going to briefly explain how to get it easily. So find a standard deviation using the calculator. The first step is you have to take this type of scientific calculator. Then first step is you have to change the mode for the SD mode. To do this, first on the calculator, then press mode key in 2 times, then you can display here SD, then under ST, then it means the here that is 1, so you have to press 1 in there, then mode is changed to the SD. That is the first step. Press mode twice, then press 1, then here you can see the mode is changed to the SD. Then second step is, then now mode is changed to the SD, then now you have to add the entries. Here the adding entries is little bit different than the other one. Then here, so you have, then now here you have to add the suppose I am not taking the same numbers, I'll explain how to add these numbers. Suppose this is the range, set of range you have to take to find the standard deviation. I write the numbers 5, then 12, and 3, and 4, and 20. So if you need to find the standard deviation of these numbers, so what you have to do now, you change this mode for the standard deviation mode, then type 5 in here, then press M plus. This means this M plus. If you click M plus, so here you can see n equals 1. In here, that's in the display, you can see that is n equals 1, right? Then 12, so then again type 12, then press M plus key, then you can see here n equals 2, right? Then you need to add 3, then 3 M plus again here, then you can see n equals 3. If n is gradually increasing when you are putting M plus, it means you are correctly input those values. Then again you have to add another 4 value, then M plus, and 20 M plus. Finally you can see n equals 5. It means if there are 5 entries, you can see n equals 5. It means you add these entries your calculator correctly, right? Then next step is, now you entered the data, now you have to find the standard deviation. To find the standard deviation, you have to follow these methods. So press shift here, then here you can press shift here, then press I think there is a mistake. You have to, why is put no need to press the mode here, that is wrong. So you have press shift, then press 2 here. First step is press shift and press this one, not this one. You have to press 2. Press 2, then here that is mentioned, you can see X bar, and here also X bar, and that's type n and n minus 1. This is 1, this is 2, this is 3. So you need to choose this one, right? So press this one, then you can find you can see the standard deviation on the screen, right? And by this way you can find the standard deviations by using the calculator. Then you can find this column. When you need to find the standard deviation, when you need to find the that is, this part is explained in this slide, that's why here that is, you can see here, then press 2. You can follow this method, right? I am writing there also, right? Then here that next one is, then if you enter 1, so then you have to create the mode. After clearing the mode, you have to repeat the same thing again, right? So here you have to clear the mode. This is the way of clearing the mode. Shift mode, then press 1, then it's come. If that is stat clear. Here you can see the stat clear, right? It means you clear the entered entries, so you have to follow the same method again. You have to enter the data again and find the standard deviation. You have to repeat this process for 25 times. If you here you have to add this all the entries at once. You can find, if you enter 5 entries, you can find this one standard deviation. Then mode clear, it means stat clear, as I explained in previous. Then add these 5 again, then find the standard deviation, again stat clear, add these 5 entries by using the previous method. Then this is the way of finding. You for all 25 entries we have to find the standard deviations by using that method. I think better to don't look at these answers, better to try it in yourself and you can check the answers. After finding the standard deviations, you have to find the sigma s. It means you have to add this all. If you add this all, you can take the sigma s as 3.2889. then you have to find the s bar. S bar means sigma s over m sigma x. Now this is the value, 3.2889 divided by m equals 25. So then you can take the value as 3.2889 divided by 25. It's come 0.1316. 0.1316. Now you found s bar. Now you can find the you can write the control limits for the s bar chart. So earlier I mentioned upper control limit equals before s bar, and center line equals s bar, and lower control limit equals b3 s bar. You need to find b3 and b4, b3 and b4 when n equals 5. Then n equals 5. Here b3 equals 0, b4 equals 2.089. so b3 equals 0, b4 equals 2.089, right? So then we can b4 means 2.089. s bar we found value is 0.1316 multiplied by 0.1316, then 2.089 multiplied by 0.1316, answers come as 0.2749. 0.2749, no, 2749. That is the upper control limit. The center line is s bar, that is 0.1316, and b3 equals 0 multiplied by 0.136, that is 0. These are the control limits for the s bar chart. Next thing is estimating the process capability. So you have to find that process is capable, so it has a high performance, it can be detect the non-conformities, right? So estimating the process control, the x bar and r charts give the information about the capability of the process relative to the specification limits. So specification limits are defined by the that person who responsible to this statistical process control. That is, there is no mathematical relationship with these specification limits. And assume a stable process. If all the data within the specification limit, so we call that this is a stable process. And we can estimate the fraction of non-conforming items any process specification limits are involved. Assume the process is normally distributed, so we are assuming this is normally distributed, so we have to use the normal table when we are doing the calculation, because we are assuming this process is normally distributed. The fraction non-conforming can be found. If you need to find the fraction non-conforming, you can find using this equation. P x less than lower specification limit, that is not control limit, that is a specification limit. So when you are doing the example, so you can understand, and plus p x greater than upper specification limits, USL not UCL, that is not control limit, that's a specification limit. And process capability ratio, again that's we call PCR or CP, so used to express the process capability, that is also used to express the process capability for the processors which both upper and lower control limits, and use an estimated of sigma. It is unknown, if sigma it is unknown, so you can write CP equals upper specification limit subtraction lower specification limit over 6 sigma. That sigma means, if that is this way, you need to find that sigma, that means r bar over d2, right? When if CP greater than 1, if this value is greater than 1, then lower number of non-conforming items will be produced. It means that process has a high performance, that is capable, right? If p greater than 1, it means that process has a high performance, it means low number of non-conforming items, there are low number of non-conforming items will be produced. If c equals 1, then assume that is the normal distribution, we are producing about 0.27 non-conforming. If that is also good. If CP greater than 1, it means that is high performance. If CP equals 1, that is also that is also good, that is assume that that is normal distributed. If CP is less than 1, then a large number of non-conforming items are being produced. It means there are so many defective items can be produced. It means that process is not a good process. And this is example. If specification are at the nominal plus or minus 0.50 of the above example, what can you say about the capability of this process? Calculate process control ratio, PCR. So here then, or if you have to solve this kind of problems, specification limits are given in the problem. Here that the specification limits given as plus or minus 0.50. Then you know that x double bar we found earlier. With the x double bar we are dealing with this specification limit. X double bar, where's the value? X double bar here 1.5056, 1.5056. then x double bar value b equals 1.5056, right? So then specification limits we can write specification limits x double bar 1.5056 plus or minus this value that is given, specification limit 50. Then upper specification limit, it means 1.5056 plus 0.50, it means that's come 2.0056. no, this value if you add, then lower specification limit 1.5056 subtraction 0.50. if you subtract this 1. that is 1.0056. now we found lower specification limit and upper specification limit. So we need to calculate the PCR using this equation. That means CP equals upper specification limit subtraction lower specification limit over 6 sigma. It means before that we need to find the sigma, right? So before that we need to find the sigma hat equals I think you remember the equation, r bar over d2, that is r bar over d2, r bar over d2, then n equals 5, no? value. So there are 5 samples, n equals 5, then you need to find d2 in here. When n equals 5, d2, simple d2, this value, this one, 2 point, simple d2 you can find as 2.236. then sigma hat you can find r bar value I didn't remember, but we used in here, no? r bar here r bar is this one, 0.3252. r bar equals 0.3252. you can substitute there. R bar 0.3252 divided by d2 2.236. so then value is 3252 division 2.236. answer is come as 0.1454. 0.1454 microns. This is the sigma hat. Sigma hat equals 0.1454, and we found upper specification limit and the lower specification limit. Upper specification limit equals 2.0056 and lower specification limit equals 1.0056. now we can use the equation CP equals again PCR equals USL or LSL, then 6 sigma. then we can find the process capability ratio PCRO. CP equals upper specification limit subtraction lower specification limit divided by 6 sigma. CP you can find upper specification limit, that is 2.0056 subtraction lower one 1.0056 divided by 6 sigma. Sigma means 0.1454. then CP you can find, if you subtract this one, here come 1 over 6 multiplication 1454, that's come 8724. it's come 1.146. Two 6 means 263 we can take, so 1.1463, that is the capability ratio CP. so here you can see CP, that is 1 point something, it means that is greater than 1. Greater than 1 means low number of non-conforming items will be produced, no? Low number of non-conforming items will be produced. Items will be produced. It means this, therefore this process has high performance. If CP is greater than 1, it means the process has high performance. This is the way of analyzing the given problem. And another thing we can do, so this is another type of question can be asked in your examination or the tutorial. Assuming that if an item exceeds the upper specification limit, it can be revoked, while if it is below the lower specification limit, it must be scrapped. What percent? Here what percent? This asks a percentage. What percent scrap and revoke is the process now producing, right? It means assuming that item means I am taking that item as X, right? So that's a probability, no? Then item X exceeds upper specification limit, that is revoked. No, so here asking the percentage, so we need to multiply it by, if it is lower specification limit, it means X less than lower specification limit, it is scrapped. Again this also need to taken as a, and we are assuming these are normally distributed. So since these are normally distributed, so we can find the probability of revoked. So here revoked, how we can find? P X minus mu over sigma greater than X. Here X is given as upper specification limit, no? Upper specification limit subtraction mu over sigma into 100%. This is what? So that's familiar for you. X minus mu over sigma, that is Z score, greater than upper specification limit. You can substitute the value 2.0056 2.0056. Mu is the X double bar, that's come X bar here, I think X double bar 1.5056 1.5056 over sigma we found in the previous slide. This one sigma, yeah, 0.1454 0.1454 into 100%. Then P is at greater than 2.0056 subtraction 1.5056, that is 0.5 divided by 1454, that is 3.4387, 4387, it means we can assume 3.44, no, 3.44, 3.44. We can't into 100%, so we can't find that value in z table, so we have to convert this as a less than value. It means 1 minus p less than z 3.44 into 100%. So 3.44 you can find using this table. 3.44, this value, no, 3.44 equals 1 minus 0.99971, 1 minus 0.99971, 0.00029 into 100%, 0.00029 into 100%. Then you can find the answer as 0.029%. That is revoked, so you have to find the scrapped also. Scrapped equation is this one. We wrote p less than x greater than 100%, so we can write p x less than LCA as lower specification limit into the 100%. Again we can write as the same way, p x minus mu over sigma less than lower specification limit minus mu over sigma into 100%. P, this is z less than lower specification limit we found 1.0056, then subtraction mu x bar 0.565056, then z also we can sigma also we found 0.1454, no, into 100%. So you can simplify this as previous way, p then z less than, then we can find the value. Here come minus value, no, here minus 0.5, no, minus 0.5 divided by 0.5 divided by 1454, again 3 point minus minus 3.44, again the same value, so we minus value means 1 minus, we can write same value again 3.44 means what is the value, 99971, 0.99971. if you substitute subtraction, then here 100%, here also 100%. If you subtract this, it comes 0.00029, no, yes, into 100%, into 100%, it is equals 0.029%. this is the scrapped, right? So if a question is given in this way, to find this you can use this method. And also we can understand one thing also from this one, here means that is scrapped means that is lower for the specification limit, that means that is exceed the specification limit. It means these entries are not in the given specification limit. It means if we add this all, p equals 0.029, then this one also 0.029, what happened? 0.058%. This percent is not in the specification limit, right? But that is good, no? Only, it means only 0.058% of products outside the specification limits. It means you can use this method also to show this process is capable. No? Why? That means if you found these two and add together, you can say what is the percentage which lie outside of the specification limits, right? So this can also use to show the process capability. And process capability ratio, then CP again. Then if the percentage of specification band, the process uses up to denoted by p hat equals 1 over CP over 100%. The CP statistic assume that the process mean is centered the midpoint of the specification band. It measures the potential capability. So p hat we can find 1 over CP into 100%. So example, previous example we used to find the p hat 1 over CP. So we need to we found the CP value, then p hat we can write what is the CP value we found. CP this one 1.1463, then 1 over 1.1463 into 100%. So we can find the p hat 100 divided by 1.1463. 87.237. Meaning of this is the process uses up about 87 of the specification band. It means 87, that product 87% is within the specification limit. That is good, no? So therefore we can write that is the process uses up approximately about 87% of the specification band. That's good, no? Right, that is the end of the part 1 of this video. So we will meet in the part 2 in the next part of the lesson.